Hey guys, it's Morgan here. Today I wanted to do a video with a few pretty short proofs just to give you some extra examples and extra resource to look at as you're working through your homework today. A couple things just to note before I get started. It would probably be helpful to have the handout with all of the rules on it in front of you, and it would also be good just to at least have read through that a couple times and be familiar with the names of all of those rules. And I apologize if there is some background noise going on here. I've got my window open because it's pretty toasty today. So, alright, let's get started. So the first one we're going to look at is A ampersand B, therefore A. Okay. So that's the first proof we want to do. Now last week you practiced getting started with proofs. So you practiced figuring out what your overall strategy was for any given proof. And there were two parts to figuring out that strategy. There are two questions that you ask yourself to get started on any proof. So those questions, let me get a marker here. I've never tried to teach anyone via my cell phone camera before, so I apologize if this is a little bit awkward. Okay, so two questions that you want to ask yourself as you get started with the proof. So first one, you want to ask yourself, what is the conclusion? What kind of a sentence is the conclusion? So if we look back at our argument over here, this is our conclusion. Our conclusion is A. It's just a plain old atomic sentence. Atomic sentence. Okay, so it's the first question. We've identified the conclusion. Now we want to figure out how the conclusion is embedded in the premises. So essentially what we're trying to do is we're trying to figure out the connection between the premise here and the conclusion. Okay, that's a key part of figuring out your strategy for the proof. Strategy. Okay. So there's a few options we've got here as we answer the second question. So your conclusion could be embedded as a whole. What that means is you look at your conclusion here and you see the exact same thing somewhere in your premises. Okay, so option one, it could be embedded as a whole. Option two, it could be embedded in parts. And what that means is that you would look at your conclusion here and you would see one or more of the parts of your conclusion somewhere in the premises. There's also a third option, okay? And you're actually going to get to that later in the week, okay? This third option requires some special attention, so we're not going to pay attention to that right now. So right now we want to figure out if our conclusion, the atomic sentence A, is embedded as a whole in the premise or in parts. Now, our conclusion is an atomic sentence, so it just has one part, right? We can't break it up. We're not going to be able to see bits of this in the premise. If we look at it, we actually see our conclusion A embedded in the premise, right? We see our conclusion A right here. So that means that yes, our conclusion is embedded as a whole in the premise. Right, so the conclusion is the left conjunct of the premise. Left conjunct. Left conjunct. So when your conclusion is embedded as a whole in the premise, that tells you, remember we're working on the overall strategy for the proof, that tells you that you're going to be using an elimination type strategy. Okay. That means your overall goal for the proof is going to be to use one of the elimination rules to break this conclusion out of the premises. Now in this case, as we said before, the conclusion is the left conjunct of the premise, right? So the conclusion is embedded within a conjunction, and we have a rule that lets us break out a conjunct from a conjunction. Okay, one of the elimination rules lets us break out bits of a conjunction. And that rule is, perhaps you've already guessed it, that rule is ampersand elimination. Okay. So in this proof, our overall strategy, remember that's what we were trying to figure out, our overall strategy is going to be ampersand elimination. And now what we've actually done is we've identified the very last step that we're going to take in this proof. Okay, and now our job is to connect that last step to the first steps of the proof. Okay, so I'm going to go ahead and get started with the very easiest part of any proof, and that is to just write out your basic assumptions. So even if you have no idea how to approach a proof, even if you really are struggling with determining a strategy, which after some practice, hopefully it won't happen, but at the very least, you can always get started writing out your basic assumptions. So in this case, we have one premise. Okay, so this is going to be a very short step. We have one premise to our argument, so we're going to have one basic assumption in our proof. Okay, so I'm going to get started here, listing out the one basic assumption. So line number 1, our basic assumption A ampersand B, and we're assuming this to be true. Okay, that's how we get started with any proof. We assume the premises to be true. So in this case, we're using the rule of assumption. Okay, so this is one of the rules, okay, one of the rules of natural deduction on your handout. This is the rule of assumption. Rule of assumption. Okay, so we've listed out our basic assumptions for this proof. We're assuming A ampersand to be true, and now it is our job, keeping in mind the strategy that we identified, how to connect, using the rules, this basic assumption with the conclusion that we're trying to reach. Okay. So, what I recommend is for you to write down